Hi folks, so the question we have in front of us here today, guys, is the road geometry question from the 2009 Leaving Cert based on the ordinary level paper. Okay, so it says here 2009 ordinary level, the accompanying map shows ground contours at 5 meter vertical intervals, or scale is 1:1000. Part A, on the drawing supplied, draw a vertical section profile along the line AB. Part B, an observation tower is to be built at A. Determine the minimum height for the tower if the ground at B is to be visible from the tower, or from the top of the tower. And then CD is the centre line of a proposed roadway which is level at an altitude of 55 metres. Using side slopes of 1 for embankments, which is fills, complete the earthworks necessary. And it says, you can see on the south side of the road, it's not in the picture, but on the south side of the road the earthworks are already done. So starting off, what we're going to do is part A, draw and supplied, draw a vertical section profile along the line AB. So just looking at our contours, we can see this contour is at 40. You have to come down to the bottom half, so I'm just going to bring this down here now a little bit so you can see it fully in the page. So on the bottom half now you can see we have 45, 50, 55, 45 and so along. So this one here is at the 25, and then at this point here it's at the 30 and so forth. Okay, so our lowest one is actually at the 25, which is where B is going through. Okay, so first of all, our scale is 1:1000. That means 1 millimeter on our sheet. Okay, so our scale, I'm just going to use this, 1:1000. So OS is what I usually write, and then IR, which is, so OS is on sheet and IR is in reality. And the distance between our contours is 5 meters. Okay, so 5 meters or 5,000 millimeters. So 5 meters is equal to 5,000 millimeters. Okay, just so we know that there. So I'll pull that a little bit so you can see it there a little bit better. And what we have to do is we have to work out what 1,000 millimeters up to 5,000 millimeters, because we know 1,000 millimeters is equal to 1 meter, and we have to work up to 5 meters. So multiplying this by 5 will simply get us the answer. So that means 5 on our sheet is equal to 5,000 millimeters in reality, and that's 5 millimeters. Okay, so that's kind of like our little magic number there, the 5. Alright, so using that, what we have to do is going to complete the vertical section profile here. The highest it goes up to is 50 and the lowest is at 25. So from the side here I'm going to put this at 20 there, and then I'm going to measure up in 5 millimeter increments. Okay, so 25, 30, 35, 40, 45 and 50. And I'll plot those in. I'm just going to project up B so I know how far I have to go there. And this one will be at 25, 30, 35, 40, 45 and finally 50. Okay, so write in my increments: 25, 30, 35, 40, 45 and finally 50. Okay, now what we have to do is, essentially, this is a vertical cutting section that is going through. I'm kind of drawing the elevation of this cutting section here with my contour heights. Okay, so at this one here, this one, point A, is at the 40 contour, so I project that up as far as the 40. The next one down, if I just come down here and follow it, I can see is the 45. Okay, so this one will go up to the 45. Okay, the next one will be at the 50. Next one is also at the 50. Next one, we're starting to work downwards now again, so this is at 45. Then we have 40. This one is at 35. Next one is at 30. This one here is at, just make sure, yep, 25. And once again at 25, which is where B is at. Right, so I'm going to pop those points in. Just So just identifying the points. Make sure I did that right. 25. Oh yeah, 30. Should have gone to there, just on that one there. So follow the 30 up. Should have been right here. Extended on a little bit far there. And this one was at 35, yep. 40, 45, 50, 50, 45, back to 40. Okay, so you can see my points there, so I'm going to plot in that profile. So I'll quickly speed up the video for that. Okay, so there you have it, guys. That is the profile along the line A and B there. And it says here on the draw the profile section along line A and B. Now part B of the question, it actually says up here, okay, and I'll read it out again. It says an observation tower is to be built at A. Determine the minimum height for the tower if the ground at B is to be visible. So this is point B here. Okay, and we're building a tower from A, which is right here. Okay, so that tower, and I will put it in green. Okay, this tower, what height does it need to be? So construction line first, and essentially if a person was standing here at B, they need to be able to see that tower, so it has to go over the top of the mountain from B. Okay, so for them to be able to see the top of the tower, which will be right here at this height. Okay, so I'll measure that then. So I'll just put that in there, and what I do then is I'm going to measure that. Okay, and remember 1 millimeter is equating to 1 meter. So 10, 20, it's coming out roughly to be 22 meters high. So I'm going to put in 22 meters there. 2 meters. 22 meters. And that is the height that tower needs to be in order to be seen from position B. Okay, and obviously you can see we couldn't go through the mountain, we have to go above it. Okay, so that's part B done. Okay, nice and easy there. An observation tower, determine the minimum height of the ground. Yep. Okay, part C then, it says CD is the centre line of proposed roadway which is level at an altitude of 55 meters. So the roadway is level at 55 meters. Okay, and it says using side slopes of 1:1 for embankments. Okay, so our fill ratio, embankments is otherwise known as fill. So our fill ratio is 1:1. Okay, what that means is if we have a road, okay, and imagine this is a cut section of a road, okay, whereby the car is sitting here. Terrible car, but you get the idea. There's the car, there's a wheel, there's a wheel, you get the idea. So there's the road, okay, and essentially the land is lower than the road. If you look at the contours on here, 50, 50, 45, okay, you can see it's all gone lower. So the land is lower than the road, so we have to build up the land to the road. So what that means is we're going to build it up kind of using this kind of triangular structure. And we're going to build it up at both sides. Now, obviously we can see here on the south side of the road, that kind of fill section has already been completed for us. And our fill ratio is in the ratio of 1:1. So for every 1 meter I travel down, I'm also going to travel out 1 meter. Okay? And in this case, what we do is we multiply it by that number that we used at the start. The distance between our contours is 5, our scale was 1:1000. So I multiply that 5 by the fill ratio. So for every 5 meters I travel down, I'm also going to travel out. 5 times 1, 5. Okay? So that 5 meters I'm going to travel out. Now, from the side of the road, we know it's at a height of 55. Okay? Level at 55. So put that in red. So 55 here. And 55 here. And coming out from the side of the road, what I'm going to do is I'm going to plot in my contours. Okay? So, and the highest or the lowest it goes to, if this is 55, we're going down. Okay, remember we're going down from the road, so we're going down 5 meters. So I'll change this to 5 now. And we're travelling out 5 meters. Okay, so going down we will be 55 down to 50, down to 45 and so on. And the lowest I have to go down to here, I'm just checking, is 10. Okay, so I'm going to mark up increments of 5 millimeters. So 50, 45, 40, 35, 30, 25, 20, 15, 10. Okay, so the height of the road is at 55 and we're going to go down to 10. So this one here will be at the 50. Pop these in, just making sure, trying to keep it neat and tidy. Yeah, I'll put it all in. I'll put it in the whole way across. Now you don't have to put the lines the whole way across like I'm doing here, but you can. Obviously on your sheet you'll be using a light 2H pencil, so it'll probably come up a little bit neater than mine is. And the reason I'm going the whole way across the road is because the road is level the whole way from A to B, or sorry, D to C I should say, or C to D, at 55. Okay, so this will be 50, 45, 30, I should say 40, 35, 30, 25, 20, 15, and then 10. And likewise at this side, you don't have to if you don't want to, but just helps me. 45, 40, 35, 30, 25, 20, and 15, and finally 10. Okay, so now what we're going to do is we want to find where those contour lines are passing through, our contour kind of gradients are passing through our contour lines. So this one here is at 45, so I'm going to plot another point right here where it crosses over. This one's at 50, coming closer. This one's also at 50. This one's at 45, 40. You can see it's quite easy to do. 35, 30, 25. This one's at 20. Then I've got 15. Then I've got 10. Sorry, wrong one there. 10, 10. Back down to the 15. Then we're on to 20. Just making sure, yeah. 25, 30, then we have 35, 40, so you can see the land is getting closer to the height of the road here now. Then we have 45 and finally 50. Okay, so as you can see there, that's the artworks necessary, so I'm going to speed up the video while I sketch that in. Okay, there we have it guys. That there is the artworks completed on the north side of the road. And what we're actually going to have to do now is, just to finish off the final question, is we want to put in what's known as our tadpoling. Okay, so essentially what we have done here is we have built up to the side of the road. Okay, so for a fill, what you usually do is, if you imagine like a little football, okay, and this is a bird's eye view here, so a little football was at the side of the road like that, and we might as well put it in the south side of the road as well. Okay, and essentially those little footballs, because the road is at the highest point, they will roll down the hill. So essentially you do these little tails which kind of look like little tadpoles. Okay, and just a little squiggle like that. Okay, and there you have it. That's what's called your tadpoling. Okay, and that just shows the lay of the land and how the ball would roll down the road. Okay, therefore the road is higher than the land that's around it, and we have built up to it. Okay, so that's the part C in that question there, guys. That question was from 2009 DCG ordinary level paper. Okay, hope you found that helpful.